Hello everyone, welcome to today's Tuva Science Connections, where we're going to be thinking about changing atmospheric carbon dioxide as it relates to MS ESS 3-5, where we're helping our students or encouraging our students to ask questions to clarify evidence of the factors that have caused the rise in global temperatures over the past century. But in order to do this, right, our students need to have an understanding of what's happened or what's going on with those drivers that impact global temperatures over time as well. So we could use data to ask questions like, how is atmospheric carbon dioxide changing over time? Or is atmospheric carbon dioxide the same or similar in different locations across our globe? So we can dive in and use the data set, the carbon dioxide data set like this, to answer some of these questions. So to orient a little bit to the data set that we're looking at, these data are from the Scripps Institution of Oceanography Carbon Dioxide Program, a fantastic organization. And there is a lot of data in this data set for us to explore. So there's 1,662 cases of data. In this example, each case is the monthly average recorded carbon dioxide for each location. So the case is kind of by month, what is the level of carbon dioxide? And then we have 7 different attributes that we can explore so that we can sort of dive in and see how carbon dioxide is different or changing or comparable or similar or different. So let's do that. Let's dive in. So to get at our first question of how is carbon dioxide changing over time? Well, let's take our time variable and put it down on the x-axis, which is a good place to think about things changing over time. As I said, there are a lot of data, so it's going to take some time. And we're looking at the changes in carbon dioxide as it's changing. So as this is sort of chugging through and it's putting all these, almost 1,600 data points out there, this is a lot of data. And yeah, while we can see what's going on, what we can also do is get a sense of, oh wait, location is one of our variables. So where do we have data from? Okay, so there are 3 different locations. Right now, we're just interested in changes over time. So let's make our lives a little bit easier in digesting all of these data, and let's just look at Mauna Loa Observatory in Hawaii. A great resource that we have to think about sort of how has carbon dioxide been changing? It's this like global gold standard set of data that we have. So we can look at these data and we can get a sense of, oh, okay, so we know that 400 parts per million is a big threshold. And so what we can do is we can add a reference line to think about, okay, so that was 400. Okay, so we've surpassed 400 parts per million, which we know by looking, but by adding that reference line, it helps us even more. But when did we cross that line? So we can add another reference line in here and we can think about, okay, so when did that really happen? Okay, it looks like it happened in and around 2015, 2016 is sort of when we crossed over that threshold. Okay, so that's interesting. Like, it seems to be increasing. Where things are going up, we could add a movable line in if we want to get a sense of like what's really going on in the data. Our carbon dioxide is increasing over time. We have passed this threshold a couple years ago, back in 2015, 2016. But what's going on around the world? Is it the similar around the world? So let's reset. And again, let's think about, okay, so we're interested in carbon dioxide. But this time we're interested in comparing across locations. So remember, we've got these 3 locations of data. So we've got Alert, Canada, really far north, close to the North Pole. We've got the South Pole of Antarctica. So we've got, the 2, as close to the 2 extremes as we can get of these long-term data sets. And then we've got Mauna Loa, like out in Hawaii in the middle of the Pacific Ocean, relatively close to the equator, not along the equator, but sort of, so we've got 3 very different locations around the globe that we're collecting information from. And just to help us make sense of it, let's color the data by these different locations to make it easier for us to get a sense. This is still a lot of data to look at. And yeah, we can sort of see what's going on, but what we can do is we can actually switch it so that we're looking at this box plot where we've got this 5-point summary of our data to get a sense of, okay, where are 50% of the data of the values for carbon dioxide over time falling in Canada near the North Pole, in Hawaii in the middle of the Pacific Ocean, at the South Pole down in Antarctica. The reality is there's an awful lot of overlap. So there's a lot of similarity across these different locations, even though they're in wildly different places around our globe. And so by diving in quickly and getting a sense of what's going on through this data set, we can start to build that deeper understanding of what's happened to the drivers of global temperature and how are they changing over time, right? So carbon dioxide's increasing. We crossed this 400 parts per million threshold around 2015, 2016, depending on what location you're in. But depending on what your location in, actually doesn't really matter all that much, right? The carbon dioxide values that we were seeing across those 3 different places were really similar. And so by spending time with these large data sets and by manipulating through, we can get a better understanding. Our students can have a better conceptual understanding of how those drivers have changed to then connect it into, okay, and so why and how are temperature changing in our atmosphere? This is obviously just one of many different activities that you can use, connections that Tuva has to different science concepts that you have. I recommend checking out the science content library for other earth science performance expectations or searching by topics. As always, if you have any questions, please let us know. With that, I hope you have a wonderful day and enjoy playing with the data.